Hey, welcome back to Engineer's Workshop. Got a little bit of this and that going on this week. I'm working on the Skinner steam engine, still scraping in the port, which that's going very slowly, which is good. Slow is good because I can't really make a mistake with it. I got the valve actuator, the slide valve actuator removed, and I want to bring you back after a bit because I'm cleaning up parts, but let me just show you, give you a preview of what we're dealing with. This is the swivel joint. It's a ball joint that goes between the rocker arm and the actual linear push rod, and this piece is solid brass nickel plated. And so a lot of these components on this engine are very, very pretty, very, show pieces. And like the packing adjusting nut here, if I can get it out. Still cleaning up on this, but once again, solid brass, nickel plated. So let's do a little bit better cleaning on this and bring you back. Also starting to work on the repaired casting for the Rockwell 16-inch radial arm saw. I'm setting that up in the K&T to do some additional cleanup cuts with the milling cutter and the rotary head feature to clean up the weld spatter and bring that bore back to round. So let's get some of these parts cleaned up a little bit and I'll bring you right back. All right, so this is the gland, I guess you'd call it, that mounts onto the steam chest. It's fairly close fit to the actuator rod. I don't know, I'm not an expert at this, but I can't see any evidence of any kind of packing in there. The packing nut loads in and is compressed by the outer nut, but if that's packing, it is rock hard. I'm not exactly sure what's used for packing, but there's also room for something to be in between that. So I'm gonna have to do a little bit of research. Maybe somebody who knows a little bit more about steam engines than I do can reach out to me and help me with this, because obviously that would account for the leakage that I see out of here. But surface of the rod definitely has evidence of some linear scoring. Although it is tight as it goes through that, so maybe it is some kind of a hard packing. And there's an area that is not as tight. I've got the slide valve actuator rod very lightly chucked after cleaning the center in this end. I'm putting a center in the lathe. I'm going to do a very light cleanup on the OD of this. This area here is, I guess, original diameter as well as by the thread, so I got something I can gauge by. I've got the lathe running at about, I don't know, maybe 400 RPM, running at 30 Hertz. So let's see what we've got. Sounds crunchier in the middle. See what kind of diameters we have on this thing. Inside the steam chest, it's 932, 931.5, 931.0, 907, 929. Yep, 907. 909. 91. 925. 927. It's basically 22 thousandths. 22 thousandths wear in the middle. It's over the threads. Threads are under that, 0.893. I could take a light cut on this, recut this entire surface so that it doesn't bell in here. And that probably would clean up all of the striations that I see and improve the surface. But then it would be sloppy in the bore of the holder. I mean, ideally we make another one of these, but maybe if we just turn it under and bore and sleeve the holder, we'll deal with a slightly smaller diameter. I'm going to have to try to improve that center a little bit more. I've only got a couple thousandths run out here, but I've got more like 10 to 15, 10 to 12 out here. I switched over to my 4-jaw chuck to hold this unusual shape here on the end, which is like a D shape. Also, I spent a lot of time prior to this trying to ensure that I was not cutting a taper. I had to shift the tailstock back and forth a bit to get it within a thousandths or so over that distance, and I'm not convinced that it's perfect yet. I suspect I might have some problems up and down, but I don't have anything perfect enough to put into the tailstock to sweep to see if I got a height issue. But I've got the indicator, I don't know if you can see it, it's zeroed at this end. And if I run the carriage down, and you can watch what happens, starting to drop. Now we're at 5. Now we're at 8, 9 thousandths, touching 10, bouncing a little. Now we're coming back up to 5, back up, back up, back up. And this is all area that still slides within the bushing. And we're back, within a thousandths or so at that end. So definitely some pinching, some hourglass figure to it there. Let me see if I can just get a parallel and have you see it from that. Pretty obvious for me. I hope you can see that on the screen. But what I'm going to do is take my new insert here and take a couple of light passes on this. I got to get my RPMs up high, and I got my feed set pretty fine. See how that material works down. Just started to pick back up at the end. I can actually see there's some pitting, and there's a pit right there. But if you look on this side, I am touching again. And I'm only touching on the high side here. So let's take a little bit more of a cut again. This time we started to pick up a little bit here. Now would be a good time to check my relative diameters at each end. 919, 9185, 921.5. 921. So still cutting a 2/1000 taper over that 10 inches. And we're got about a 3 to 5 inch portion that's not cleaned up. So we'll dial in another 5 and go again. Well, I've got what I would call an amateur machinist finish on this part. It didn't seem to matter whether I used carbide insert. I even tried ground and polish, honed up high-speed steel insert. I just couldn't get any better than this. And there's obviously some little hard things in here that I can feel. So instead of trying to keep chasing surface finish, because I'm already down quite a bit, this started out at 0.932, which I don't know, what's that, a 15/16 nominal at the steam chest end, and about 931 at this end. In the middle, in the worn area, it was like 907, which was, 25 thousandths wear compared to the ends. I actually had to go a little bit under that. I'm about 895, let me double check that. 894.5, 895, and yeah, I'm about the same here. So I got the taper out of it, which was good. I'm still a little bit over the OD of the threads, but from this point, I'm just gonna try to use a combination of flat file and emery paper and get a smoother finish, a little bit of a crosshatch maybe, so that this reciprocates in the packing, carries a little bit of oil with it, and obviously it's sloppy now in the guide, so I'm gonna have to address that at a later point. So let's keep polishing on this. Certainly feels a lot better. Well, can't really feel the striations that I can see. And the crosshatch is somewhere between a 30 and a 45. Could have slowed down the lathe a bit and gotten that bill closer to 45, but I'm gonna call that sufficient for a quickie repair. I think long term might end up making a new one of these out of better steel. That'll be a fun project when the steam engine starts seeing a lot of service. Okay, so here's our pushrod system, somewhat reconditioned. This came out really well. Finished diameter is just over the threads. This is the device that plugs into the steam chest. We've got a pilot diameter. We've got what looks like a kind of a graphite gasket. This is cast iron, and I believe the outer half of this is hard rubber packing, which is almost indiscernible from the steel bore, but I believe that will come out. This is the packing nut. This is solid brass. Not a real close fit, but one of the things that you'll notice now that we recondition this rod is very loose fit, including in here. So to prevent the syndrome of throwing a hot dog down a hallway, I am going to bush this. I'm going to find an oil light bushing that is smaller than the diameter of the rod, bigger than this. Turn it to be a light press, probably put a little chamfer on here. Press the oil light bushing in, bore it to thousandths over the size of the push rod, and then deal with the packing. I'm researching packing now. I know that McMaster Carr has some Teflon packing. They've also got some graphite packing that's like a tape that you wrap around a shaft and then build it up, or wrap it around a valve stem. So there's a number of ways we can do this. So moving on from there, we've got the packing nut, which is solid brass, nickel plated. And we've got this cool ball joint. When I looked at this, I thought, oh, it's not a sphere because it's got this flat in the middle, but it has to be a sphere, otherwise it wouldn't pivot. And so this two-piece socket, which is also solid brass, has some matching stamps on it. This fits together tight, line to line. But if you put the ball joint in it, and you can see this ball joint from this orientation has just a few degrees of freedom, which is all it needs. But if you put that together and then put this on it, you end up with a gap. And so you can adjust the clearance between these items by how tight you put the clamping screws in. And the clamping screws are threaded into this piece. This piece is threaded, this piece has a clearance hole. I'm going to just go ahead and run this in here temporarily. I didn't clean these threads out, didn't chase them, but they have been sitting in the solvent bath. All this hardware is also nickel plated. So we've got nickel plated nuts, which basically act as a lock nut or a jam nut against the back side of this. So I'm assuming that you adjust for your clearance and you get just a little bit of play in that rod, but not slop, and then you lock this nut on the back side. Then this nut goes on to the actuator rod. There's a cross pin hole to keep that guy from turning. I measured the length from that surface to the end of the rod. And I also measured from the end of this rod to its jam nut. But let's go ahead and put this together so you can see it in its finished form. I'm not going to run that packing nut on all the way because there's an area of thread here that needs a little bit of work itself. Here again, I had a specific distance from the end of that rod to the face of that nut to maintain the correct overall length of this assembly. And so what you've got now is a mechanism that can go from a pivot on this arm, and that slight bit of oscillation is taken up in the ball joint, and then we've got linear actuation of the slide valve rod. Pretty slick system. I wish somebody didn't, beat on these with a hammer over the years, because those would be really nice if they were in pristine condition. Even the hardware, the nuts were looks like copper and then nickel plated. So I'll get to restore all of these items as well. And of course got the drip tray that sits underneath this, catches any steam and oil drippings and funnels them back through into the machine base. You can see several layers of the original color on this. The Skinner was pretty much a bright red, maybe a fire engine or even a little bit brighter red than that. So it gives us an idea of what color to paint this in the future. Hope you enjoyed that. A little bit of an opportunity to play with some of the components on the Skinner steam engine and get a little bit closer to actually seeing that thing run on compressed air. I think sealing up that packing on the valve rod, because I mean that steam chest is 150 psi, and you know air was just blowing out of there. Of course, air was blowing out of everywhere. We still got the scoring on the valve surfaces, valve seat surfaces that we got to address. The valve itself is good. The interface between the, let's call it the valve piston and the valve piston standoff, it's not real great. That should really be renewed, but that's kind of a job for more than this lathe can handle. Gonna have to do that when I got the Monarch up and running, hoping to get it sealed well enough to do a demo on that engine just running on compressed air. So what else we got going on? I am doing some work on the radial arm saw piece, trying to clean up that and get it back installed. I originally was going to include that in this video, but I took that footage out because there's going to be enough to do a video of itself. And I don't know if you noticed, but up in the very corner there, I've got 2 security cameras that are live now in this building, and those are power over Ethernet cameras. They are hooked out so that I can see them from the phone app, and that's pretty cool. I don't have the security software running just yet. The laptop that I intended to put up there and just reside in this building died, so I'm getting another one set up to be the actual surveillance system for this building, which will record, you know, any cars or people that it sees in here, and just, you know, progressing along as best we can here. So hope you enjoyed it. Thanks again for tuning in. Thanks for all the new subscribers. I'll try to get with you again next week, although I am going to be taking some time off work, and we got to prep a house for sale up in Ohio, so there may not be a video next week, but I still got some content that I could work on. You know, who knows, we'll see. And once again, from Engineers Workshop, as always, stay safe.